Ernest Rutherford and his gold foil experiment were essential to the discovery of the nucleus. The gold foil experiment consisted of a piece of gold foil, which is very much like aluminum foil, which was placed in the center of a zinc sulfide ring, also called a fluorescent ring. In front of this ring was a radioactive source. In this case, it was an alpha particle emitter. Alpha particles are positively charged, and that is important to remember during this experiment. The ring would light up if an alpha particle hit it. When Rutherford shot the alpha particles towards the gold foil, he expected them to pass right through. Most of the time, he was right, but sometimes, however, the ring lit up to the left or to the right of the foil, and sometimes it even bounced directly back. Let's break down what Rutherford found. He hypothesized, based off the way the particles veered off course, that there must be something positively charged in the atom, and when the alpha particle gets too close, it changes direction. He explained the particle bouncing back because of the particle hitting whatever was inside the atom head-on. Prior to this experiment, the only model of the atom was J.J. Thomson's plum pudding model. But a better way to understand it is to think of it like a chocolate chip cookie. The chocolate chips are the electrons, randomly placed in a positively charged substance, kind of like the dough of the cookie. This was proved wrong by Rutherford's gold foil experiment. Now, let's learn a little bit more about Ernest Rutherford himself. He was born on August 30th, 1871 in Spring Grove, New Zealand. He was the fourth of 12 children and only the second son to be born into his family. As a child, Ernest spent most of his time after school milking cows and helping with other chores on the family farm. Weekends he spent swimming in a creek with his brothers. At the age of 10, he was handed his first science book. This was the book that inspired his very first scientific experiment. The young Ernest constructed a miniature cannon, which to his family's surprise, promptly and unexpectedly exploded. In 1890, Rutherford landed a scholarship to Canterbury College in Christchurch, New Zealand. At Canterbury College, Rutherford's professor fueled him with enthusiasm for seeking concrete proof through scientific experimentation. In 1895, he became the first research student at the University of Cambridge's Cavendish Laboratory in London. Here, he was invited by Professor J.J. Thomson to collaborate on the study of X-rays. Little did Rutherford know that in the near future he would be debunking his mentor with his own gold foil experiment. Rutherford left Cambridge in 1902 and took up a professorship at McGill University in Montreal. At McGill in 1903, Rutherford and his colleague Frederick Soddy introduced their disintegration theory of radioactivity, which claimed that radioactive energy was emitted from within an atom and that when alpha and beta particles were emitted at the same time, they caused a chemical change across elements. Rutherford and a Yale professor, Bertram Borden Boltwood, went on to categorize radioactive elements into what they'd called a decay series. Rutherford was also credited with discovering the radioactive gas radon while at McGill. Regarding his legacy, Rutherford was awarded with countless honors during his career, including several honorary degrees and fellowships from organizations such as the Institution of Electrical Engineers. In 1914, he was knighted. In 1931, he was elevated to the peerage and granted the title of Baron Rutherford of Nelson. He was also elected president of the Institute of Physics that same year. On October 19, 1937, Baron Rutherford died in Cambridge, England at the age of 66 from complications of a strangulated hernia. The scientist who had always been nicknamed Crocodile by his colleagues for always looking ahead was buried at Westminster Abbey.